Okay, this video tutorial looks at the mathematical strand of networks, and more specifically, we're going to focus our understanding on the shortest connection. So basically, what is the shortest connection? Well, a shortest connection problem is determined by basically finding the most efficient way to connect a set of nodes. So for example, if you have a look at this garden here, there's a set of 4 garden sprinklers that need to be connected to the tap. All right, we have the tap here, and we have the 4 garden sprinklers here. Now, if they're all connected directly to the tap, okay, that's one method. However, it probably uses more piping than it needs, or than you would need to in order to get water to all of the sprinklers. All right, so basically they don't need to be directly connected to the tap, but instead they can be connected to each other. All right, so a more efficient method of connection is shown alongside here. All right, where you're connecting from the tap to all the sprinklers, all right, and using less tubing. What you will notice is that this diagram looks very similar to a spanning tree. All right, and obviously it doesn't have a connection, but this is where the spanning tree sort of method that we talked about a couple of lessons ago is going to come into play. So there's a couple of algorithms that we can use to find the shortest connection. The first one we're going to talk about is Prim's algorithm. So basically we start with any node, all right? And then we join the node that we're starting with to the nearest next node. And if there's 2 or more nodes that are an equal distance, then we just choose one of them at random. Once we've done that, we join the node which is nearest to either of those already connected. All right, and we continue joining those nodes until all the nodes are connected in a spanning tree. So for example, it says find the minimum spanning tree for the following network. Well, if we can select any node, all right, say we select E, I'll just follow the example rather than confuse you. If we select E, which is here, the node that's closest to us is D. So we have to go E to D. All right. Once we're at D, we then go F, because that's the closest one. All right, so we include D to F. We then include F to G. Okay, so there's part of our spanning tree already. But remember that if we were going to go from F to A, that's going to be 16. We don't want to do that because D to A is only 15. So what we're going to do there is we're now going to go from D to A. We're then going to go from A to C, because that's only 12. E to C is 18, so that's too big. So we want to go A to C, which is 12, and then obviously C to B, which is 6. So the total length, if we add all those together, we've got 5, 9, 11, 15, 12, and 6. That's going to give us 57 units. And it looks like our spanning tree is going to look like this. All right, where we've connected all the nodes, but we don't actually have a circuit in there. So another example of an algorithm is Kruskal's algorithm. So basically the difference here is we choose an edge rather than a node. So we choose edges one at a time, taking the shortest edge at every stage, while making sure that there are no circuits formed. So if we start with the shortest edge, all right, and in this particular case, the shortest edge looks like it's F to G. Okay, here, because that's 2, great, okay. We look at the different lengths. We've got all the lengths in our table here, and we include the edge that does not complete the circuit. All right. So it looks like we then go smallest edge is here, which is great. We don't want to include E to F. Okay, we reject that because it's going to make a circuit. This is our smallest one here. All right, so we're going to have something that looks like that. We're also going to have something that looks like this. All right, and then we're going to go up and around to there. So we won't include B to E. We won't include D to G or C to D, okay? Because they're the ones that are going to make a circuit. All right, these ones here. So we just follow them all till they're connected, and then we add all our lengths, and we end up with a total of 23 units. Okay, so let's have a look at a practice question here. Basically, you need to use Prim's algorithm to find the minimum spanning tree and then state the length of the shortest connection. Please feel free to pause the video. Once you think you've got the correct answer, continue the video and we'll see how you went. Okay, so if we're going to look using Prim's algorithm, basically remember we need to choose a node. I'm going to choose Y. Doesn't particularly matter which one you choose, but I'll choose this one. And we follow the shortest length. So we've got X, shortest length is to W, and then the shortest length here is back to Z, and we've covered them all, and that gives us a total of 14 units, which is great. Here, I might choose D. We go to shortest length is to A, which is great. And then the shortest length is then going to be, from D to C is also the next shortest length. And from D to B is then my next shortest length. So that's going to be my spanning tree. And that's going to give me, what's that, 45 at 30 is 75 units in length.